Right. Now, moving on to our second topic, electric potential and potential difference. So this is where, as I was talking about the voltmeter, how it is, connected in parallel and whatnot. First of all, I just want to ask, am I audible to everyone? Okay, good. So electric potential and potential difference. Now, what is electric potential and what is potential difference? These are two new terms that I'm pretty sure, especially most of you who have come into grade 10 will be hearing for the first time. However, you'll see that it's actually very, very, common in our life. So, when we have in our house, we have different outlets or things where you plug stuff in. It's sometimes 110 volts, sometimes 220 volts, sometimes 240 volts, things like that, yes? These are measures. I'm going to have to. See, if you come into my class, this is a free class and I expect a modicum of discipline here. If you want to just troll in this class, I will kick you out, just so you know. So whoever is drawing on my screen, I have disabled annotation, but just know that that will not be tolerated in this class. Anyway, coming back to this, electric potential and potential difference. So what is electric potential? So you know how, let's actually take the analogy in this, let's say this, what NCRT has given us. What makes the electric charge to flow? Let us consider the analogy of flow of water. Charges do not flow in a copper wire by themselves, just as water in a perfectly horizontal tube does not flow. If one end of the tube is connected to a tank of water kept at a higher level, then such that there is a pressure difference between the two ends of the tube, water flows out of the other end of the tube. Obviously, if you hold if you have water, for example, that's how a water slide works. When you have for example, let's say this is a pipe, and you're putting water from here, obviously it's going to flow down and come out of here. That's quite obvious due to gravity and pressure, what they said, pressure difference here. For flow of charges in a conducting metallic wire, the gravity, of course, has no role to play. The electrons move as if there is a difference of electrical pressure. This is called potential difference along the conductor. So electrical potential difference, I guess we can say, is the force that prompts electrons to move. So the force that prompts electrons to move and conduct electricity is called potential difference. So again, a difference of electrical pressure called potential difference along the conductor is called potential difference. It is the force that prompts electrons to move, and this difference in potential may be produced by a battery consisting of one or more electric cells. The chemical action within a cell generates a potential difference across terminals of the cell, even when no current is drawn from it. When the cell is connected to a conducting circuit element, the potential difference sets the charges in a motion in the electrical conductor and produces an electric current. So when the cell is connected in a circuit, for example, this is the cell, this is the circuit, the positive and negative terminals are there, obviously. And these two terminals and the chemical energy in the cell, they create a potential difference between terminal A here and terminal B here. Since there is an electrical potential difference between these two terminals, electrons are prompted to move in this direction. Again, moving from positive to negative. Resistance less. Sarfaraz, the last 10 minutes of the class are for doubts and things like that. So right now we will, move forward with this. And then the last 10 minutes, I'll take doubts and numericals and things like that, which you have doubts from back exercises and things like that, because there are many students here who haven't, as of yet, studied this chapter yet. They just came into grade 10. So electrical potential difference, I guess you could say, is the difference of electrical pressure across 2 points that makes electrons move from one point to the other. It can also be defined as the work done to move unit charge from infinity to a point, or work by Q, which will actually, I'll leave this for now. We'll see that in the later thing. That's a mathematical expression for potential difference. So again, as it says here, in order to maintain the current in a given electrical circuit, the cell has to expend its chemical energy stored in it. We define electrical potential between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to the other. That's what I just said. So work done per unit charge. This is the I guess you could say, one of the formulas for electrical potential, which is denoted by V. Now, electrical potential is denoted by V, as I said, and its SI unit is also denoted by V, or volt. That's where I was saying, like 110 volts or 220 volts, etc. That denotes the electrical potential difference between 2 points and how much force or electrical potential there is in your outlet. So when it says work done to move a unit charge from one point, let's say you have charge A here and you want to move it to charge B. You need to expend some force to move charge A to charge B in a given time. So in a given time, if you want to move charge A to charge B, the work you need to do to move this charge from A to B, that is called that we can define as electrical potential difference. So the work done to move a charge from one point to another is defined as electrical potential difference. Now its mathematical expression, as I already showed you, is W by Q. V is equal to W by Q. So work done per unit charge. So if you want to move one unit charge from A to B, the work done for that unit charge or per that unit charge is known as potential difference. It is denoted as V. SI unit of electrical potential difference is volt, named after Alessandro Volta from 1745 to 1827. That's his lifespan, an Italian physicist. 1 volt is the, what does it say here? Let's look at this. Is the potential difference between, okay, so this is defining potential difference as like the same way we defined ampere, we define potential difference. Now, so we know that V is equal to W by Q. And again, we know this is volt. The SI unit of this is volt. Charge, we already know SI unit is Coulomb. And you must have learned in 9th grade that the SI unit of work is joule, Joule, which is denoted as J. Give me 1 second. Okay, so coming back to this, so we have V or potential difference as volt. We have W as joule, which is denoted as J, and Q as C, which is Coulomb. So same way we denoted or we define ampere as 1 Coulomb per second. Same way, putting the values of SI units in this formula, we can define 1 volt. So 1 volt is equal to 1 joule per 1 Coulomb. So 1 volt is equal to 1 joule per Coulomb. So that is, again, we saw the, this is the, I guess you could say, the mathematical definition of volt. It is 1 joule per 1 Coulomb. And moving on from that, we have potential differences measured by a means of instrument called voltmeter. Like I said, voltmeter. Voltmeter is always connected in parallel. What does that mean? That means, as we saw, for what do we call it? For an ammeter, it is connected inside the circuit, in between the circuit, in between the wires. Now, a voltmeter, for example, if we have a circuit here, this is the battery, for example, we have a switch, it's plugged in. Then a voltmeter, if this is point A, this is point B, then a voltmeter is not connected inside the circuit, but is rather connected outside the circuit. And it measures the potential difference between point A and B. Why is this? Because potential difference can also be defined as the electric potential here and electric potential here. So if we say potential difference, so if we want to measure between A and B, then electric potential difference will be potential difference, as we know, is subtraction. So it will be defined as electric potential at A minus electric potential at B. So since it is not measuring the current through the the circuit, but rather measuring the difference of 2 points on the circuit, it is connected in parallel, which means it is parallel to the circuit here, but it is not in the circuit, it's connected outside, and only 2 points are in contact with the voltmeter. This is what it means to be connected in parallel, while ammeters are usually connected in series, which means they're connected between the wires because you need the current to flow through the ammeter for it to be measured. Now we have another numerical problem here. Again, not that hard, simple application of formulas. We are given how much work is done in moving a charge of 2 coulombs across 2 points having potential difference of 12 volts. So again, if you guys want to solve this, I'll give you like 5 minutes. Okay, so 23 joule, I do not think is correct. Let's look at the answer. It's 24. I think that might have just been a typo. Yeah, 24 joule. Yes, that's correct. Again, using simple formula application. Okay, so I think we'll stop here for today. And now I can take doubts from anyone. You guys can leave your doubts in chat. I think I already had 2 doubts from Sarfaraz. So yes, okay, let me just look through this. Okay, so only 1 doubt is here. Sarfaraz, you can send your numerical doubt in the chat as well, or whichever question it is. If it's from the back exercise, you can let me know. As for, you asked, why is the resistance less when resistors are joined in parallel? So, I mean, it's obvious when we have 3 resistors, for example, joined in parallel. Then when the current flows, it flows individually through each of these, right? So, okay, I'll explain this mathematically. When you add, for example, in series, you add RS is equal to R1 plus R2 plus R3, like this. So obviously, and then 1 upon RP is equal to 1 upon R1, 1 upon R2, 1 upon R1 plus 1 upon R2 plus 1 upon R3. The reason it is, less is obviously, even if you look at it mathematically, adding whole numbers 4 plus 3 plus 5, etc., or whatever you want, then 4 plus 3 plus 5, for example, will obviously be bigger than 1 upon 4 plus 1 upon 3 plus 1 upon 5. When you add fractions, then their sum will always be less than whole numbers, because each yeah, exactly. As Muhammad said, I was explaining mathematically exactly. Sarfaraz, you can look in the chat as well, what some of our other students have also explained it. But mathematically, when you add whole numbers, it'll usually be bigger than fractions. And again, when like Muhammad said, when you connect in parallel, there are multiple ways from where the current can pass. So there's not that much resistance, because when you connect it in series, there is a continuous set of resistance. Like for example, if there's two resistors connected in series, so it'll have the resistance of this plus resistance of this. But in parallel, when you connect it, there's a lot of people joining now. When you connect it in parallel, there will be resistors individually on each branch. What does that mean? That the current can pass through this, can pass through this, or it can pass through this. So it doesn't have to have the contention or the it doesn't have to go through the resistance of all three resistors at once. You know, like it doesn't have to pass through. So for example, if it takes the first branch, it'll only have will have to take the resistance of this, and similarly, so forth, so on. So mainly, like Muhammad said, you can look in the chat. Look in the chat. It's a good explanation. In a parallel circuit, the net resistance decreases because there are more paths for the current to pass through. So there's more than one path for the current to pass through. Therefore, there is less resistance. Good job, Muhammad. I like that explanation. And for your second doubt, when you said like having Ohm's law questions with more than one resistor in it, could you give me an example? That's a very generic term. Like what? When you have to arrange the different resistors to get a certain resistance, like net resistance, or what is it? Okay, so we'll take a exercise question for that. It essentially, you just have to try out different combinations and use your knowledge for, you know, how many, you know, if you use parallel, then the resistance will be less. If you use series, resistance will be more, and you just have to find out the combination which works. So for example, we had, I believe there was a question here. Yes, question 11 here. Show how you would connect three resistors, each of 6 ohm resistance, so that the combination has a resistance of 9 and then 4. So automatically right off the bat, if we want 9, first thing that comes to mind is series. Why? Because series always has the highest resistance. So first, obviously, we'll try all 3 as series. So if all 3 as series, we can say 6 plus 6 plus 6 is not working, because obviously 6 plus 6 plus 6 is 18, which is more. So then we have to change the combination. So what we do is we do 6 plus 6, and then we change the combination to 1 upon 6. So these two will be series. Or actually, we first add 2 of them in series, which is 12, and then add the third one in parallel. So the diagram would look somewhat like this. So this is resistor 1, this is resistor 2, and then this is resistor 3. So these 2 are in series, and these 3, and then this net resistance and this net resistance is in parallel. So now, when we have to calculate the series resistance for these 2 resistors, it is 6 plus 6, which is equal to 12. And then when we have to calculate the total resistance, which is in parallel, we do 1 upon 12 plus 1 upon 6, which is equal to 1 upon RP. So we take LCM as 12. Oh wait, no, I did I did the second part first. So I did the second part, my apologies. So this is for 4 ohms. So 1 upon RP, so you take LCM as 12, and then you can take, you know, this will be 2 plus 1. Okay, let's do this again, because I accidentally did the second part first. So I did the I did the second part first. So first part, obviously, when we see it's 9 ohms, we have to essentially, again, like I said, we have to check the different resistances, and we have to check the different combinations. So if we have 9 ohms, series is not cutting it. If series doesn't work, then use parallel. 1 upon 6 plus 1 upon 6 plus 1 upon 6, which is equal to 3 by 6, which is equal to 1 upon 2, is equal to 1 upon RP. So then that means that 3 by 6 is equal to 1 upon RP. This again is not working because it's only 2. Then we have to find out the other different combinations. So now if we do, for example, we connect 2 of them in parallel and 1 of them in series. So for example, you do this, and then you have 2 of them in parallel. Then we have, one second. We have 6 plus, then you have RP. So RP is going to be equal to 1 upon 6 plus 1 upon 6 is equal to 1 upon RP. So Rp will be equal to 6 by 2, which is equal to 3. So to get 9 ohms, we'll keep 1 as series and 2 as 1 as series and 2 as parallel. So we'll get 6 plus 3, which is equal to 9. So essentially in this question, it really doesn't have exactly like a streamlined method. You just have to use your knowledge of parallel and, you know, you can say series resistors to try to get the highest or the required resistance. Now, so first of like one thing you can start off with, obviously, as you can see here is, since I saw it was 9, there are 3 resistors of 6 ohms. So that means 18 ohms total if it's in series. And if we do only parallel, then we get 2. So one inkling that you can try is, since it's between the 2 extreme values, it will be a combination of parallel and series, right? So then there's only 2 combinations that can be here. You can either keep 2 in parallel and 1 in series, or 2 in series and then 1 in parallel. So you try those 2 combinations and you find whichever gives you the net resistance. So it essentially just depends on different combinations, and you just have to, I guess, trial and error it. That's how it'll work. Any other doubts? Anyone?
I had one.
Sure.
Yeah. So the current was given 1 ampere, and we got to find the number of electrons passing in 16 seconds.
Right. We're given, sorry, what?
The current was given 1 ampere.
1 ampere.
And we got to find the number of electrons in 16 seconds.
16 seconds. Okay. So first of all, we know that I is equal to Q by T. Yes. So I is equal to Q by T. So then we get Q is equal to IT, which is equal to 16, right? So we have 16 coulombs. See, and then this is why I said that formula was important. To find the amount of electrons, we use Q is equal to NE, because we know the charge on the electron is 1.6 times 10 to the power minus 19. And we know that coulombs is 16. So 16 by 1.6 times 10 to the power minus 19 will be equal to number of electrons. So when we do that, we'll get what this is, 10. So 10, so this will be 10 to the power 20 electrons, N. So basically,
this type of questions can be asked?
Yes, they can definitely be asked.
Yeah, I didn't know this formula.
Yeah, this formula, well, when I was in 10th grade, I also had a little bit of problem with this. But yeah, this is an important formula, because especially like you said, to find the number of electrons, this is the only formula that you will use. So so basically, again, the flow of this question is that first you're given I, you're given T, you find the charge, and then you use this formula Q is equal to NE to find the number of electrons. Because, and also you need to know this value, by the way, times 10 to the power minus 19 coulomb for electrons, the charge on an electron. You kind of have to learn it because it won't be given in the question. This is a constant value. You need to know this. So I would recommend that you memorize it. So yeah.
Now, they can also give the electrons and find the coulombs.
Yeah, they can give you, for example, number of electrons are given and you need this, and you have to find number of coulombs. They will also give you that. So it revolves around these 2 formulas.
Oh, thank you.
Yeah. Okay, any other doubts? If not, then I think we can end this class. However, before you guys leave, I would ask.
I have one, Rayyan.
Yeah, go ahead.
Yeah, just check. Yeah, 3 2 resistors A, B, C are connected, and there's a figure given. Okay, but then all of them are parallel. So each of them dissipates energy which can withstand a maximum power of 18 watts without melting. Find the maximum current that can flow through 3 resistors.
I didn't really get that question. Sorry, can you repeat? Or actually, Sarfraz, listen. If this question has a diagram, then
it doesn't have a diagram. They just told in the question that as shown in the figure, but there's no figure here, and it's a question bank from NCERT, and I don't understand this one.
What? If there's no figure given, then there's a typo in the question. I mean, what does it say? It's all in parallel. So, like, for example, if I drew this, would this be correct?
I guess, yeah. That's why it's written. It's written in parallel.
Okay.
And each of them dissipates energy, which can withstand a maximum power of 18 watts without melting.
18 watts. Okay.
Yeah. We have to find the maximum current that can flow through the three
We have to find
resistors.
I. Yes?
Yeah. Yeah.
Okay.
With three resistors.
So are the values of the resistance given in each the resistors?
No, it's not given.
Typo. You can't solve the question. Because what you would do essentially is we are given power 18, yes? So we know P is equal to VI. The formula you would use for this, I'll let you know if we were given the quantities of these resistors. The formula you would use is P is equal to VI. So once there's another formula, V is equal to IR, which we will get to from Ohm's law. So I square R. So we're given P. We could, if we were given the values of resistors, we would have been able to find R. And then we would just find I from this. So I would be equal to under root P by R. However, if we're not given the resistance, then it's impossible to solve the question because there's two quantities that we don't know. So I believe that that's a typo. Is the solution given in the back? What have they done? Because if they've given the values of
I'm not sure. I haven't seen the solutions yet. It's just a complete question bank.
yeah,
And in the bracket, it's written NCERT exemplar.
Yeah, I'm pretty sure, as Abdi said here as well, I'm pretty sure the resistance would be in the figure because it's not possible to solve this question if you don't know the different resistances of the resistors, because there's no way to calculate the resistance. Sorry, is this from like the NCRT question bank from like the official one, or like Arihan Tora Oswal or something like that?
No, it's an I'm not sure. It's a 2019 question bank. Science with Zam ID, I guess. Zam ID.
Yeah, sometimes those question banks, they have typos. So yeah,
Okay.
the way you would do the question is this: P is equal to I square R, and you would be given the resistances. So you will find R, and then you will find finally you'll find I. However, obviously there's no resistance given, so that's a typo. But the formula you would use in this question is this: P is equal to I square R. Okay. Doubts? Any more doubts? Otherwise, I will end the session. And while the doubts are somebody asking the doubts, the rest of us can leave, or the rest of you can leave your the rest of you can leave your two things. Leave your, what do we call, feedback for the class, as well as your email in the chat box, because so I'll use the chat or your emails for contacting you for the next class, which I'm pretty sure I'll try to keep it every Saturday, same time. However, if you can leave your chat or your email in the chat box, as well as your feedback for the class, that'd be great. So any more doubts? Anyone? Okay, so I guess you guys can just leave your feedback and email in the chat, and I'll just give you some time, and then once we have everything's done, I'll just end the class since there's no more doubts. You guys can also leave any feedback, anything. Yeah, I would say if you want to understand the entire class, then you would want to be punctual, because we move on sometimes. So yeah, and also if you have anything you would like to see in the next class, any more improvements, if you could if you want me to teach in a different way or something that you could tell me that would improve my teaching, that'd be great as well. Because I mean, to be honest, I'm also learning. I'm not a teacher, but I'm trying my best. So any help would be great as well. Uh, okay, so I think that'll be all for today. Thank you everyone for attending. I hope it was informative. And yeah, I'll see you guys next time. Hopefully it'll be same time, Saturday, 2 o'clock KSA time. Or if you guys are from India, then that'll be around 4:30 your time. So yeah, okay. Thank you everyone. I hope it was informative, and I will see you all next time.